Okay, so I have added some free response questions just to help my students out the for the homework. It's not just multiple choice because the test is not just multiple choice, and so I wanted to go ahead and do the solutions for those. So this first one says predict the outcome of the following acid-base reactions. Draw in the curved arrows that demonstrate the movement of electrons in this reaction. So the first thing you want to think about is for acid-base reactions, what is my acid? And that's usually going to be the thing that, or you could also think, what is my base? But I typically think, what is my acid? That's typically going to be the thing that has an available hydrogen. But also you can think of it as, what is my base? And so this being negative, this is more nucleophilic. So it's more likely to act as the nucleophile. So however you want to think about it, either as basicity or acidity, whatever. I think of it in terms of acidity. I'm actually going to change it to look like this. So this negative here is drawn to the partial positive on this hydrogen because this strong electronegativity. So this negative is going to come and take this hydrogen and it's going to leave the electrons behind. And so we'll end up with this structure. And if you want, you can draw the implied hydrogen that came from here. I'll draw it in purple, but you don't have to. You could just do the blue and that would technically be right. And then what we left behind over here on our nitrogen, there was already a lone pair there, but when the bond broke, and I sometimes think it helps to like draw in, these electrons make up this bond, and those electrons left, that curved arrow isn't very good, but I can draw like those electrons left and went and joined the nitrogen. So now it looks like this. And now our nitrogen, if you calculate the formal charge, there's 5 things on nitrogen on the periodic table, minus 4 electrons and 2 bonds equals -1. So this will be negatively charged. So that's the curved arrows. And then if you want to check and make sure, like, did I do this right? You can always compare the acid and the conjugate acid. And the conjugate acid, you can define it as like, the acid is the thing that loses the hydrogen going this way, and the conjugate acid loses the hydrogen if we went backwards, if you did the reaction backwards. You could also think of it as whatever the base is with its hydrogen. This started as the base, so once the base gains a hydrogen, it becomes the conjugate acid. So we can compare the pKa's of these two things, and the pK of this is like 38, I think, and the pK of this is 50. So this side of the reaction is going to be more favored, but it's also, it makes sense that the thing that was more basic or more acidic is no longer going to be. So, it makes sense that our acid lost its hydrogen to something that was that would ultimately become something less reactive. So that's sort of how I think of it. It's like, oh, if we're going from lower pKa to higher pKa, then we know that this reaction is favored. So that also helps me when I'm trying to figure out, how a reaction would go. Okay, and then for the next one, we're going to label the acid and the base. So again, I'm looking for the thing with an available hydrogen or the thing with extra electrons is negatively charged is usually going to be your base, and the hydrogen is usually going to be your acid. And we know that it ends up where this has, see this hydrogen on this side, we have a hydrogen and we lost it. So something that goes from having a hydrogen to not having a hydrogen, that is definitely your acid. If it's losing a hydrogen, that's your acid. Now we can look the other way, and what started with a hydrogen lost a hydrogen going this direction. So I'm going to label this as my conjugate acid and my conjugate base, because now if we wrote the reaction in reverse, if you did this plus this, put my lone pair in the wrong place, it would become this. So if we're looking at it that way, it's clear that this is your acid. So it's sort of like when we talk about acid and base and conjugate acid, it's like the acid is the way that it's written, and the conjugate acid is if we did it backwards. That would be the acid if we wrote the reaction in the reverse. So now I've labeled the acid and the base and the conjugate acid and base. And next I'm going to give the pKa for the acid and the conjugate acid. So I'll erase where I drew it backwards so that you can see. That's just for demonstration purposes. You don't need to have that in your mind or anything. So I'll write the pKa here. The pKa of this, let me look on the pKa chart. I know that in general alkanes are 50 and alkenes are 44. I think maybe, I do know this one. I don't know what I was thinking. We're not looking at a hydrogen off of here. That's what I was thinking for some reason. We're looking at this hydrogen, and this hydrogen is like an alcohol. Usually alcohols are 16 to 18, but because of resonance, this has a lot of stability, and so therefore it becomes more acidic. And actually, if you look at the pKa table, this is actually the pKa equals 10. Because this is C6H5OH, phenol. And phenol is because if we, lose our hydrogen and then we have all these resonance structures where the negative charge isn't just concentrated on one atom, but it's able to be shared around the ring, and that makes the impact lower, and so then therefore the molecule's more willing to give up that hydrogen, so that makes it slightly more acidic. So that's why phenol is more acidic than typical alcohols. But over here, this is a typical alcohol, so it'll be in the 16 to 18 range. So now we wrote the pKa for each one of those, and which side of the reaction is favored is always going to be the less reactive side. And the less reactive side is less acidic, because if you think about acidity, it's like how much is it willing to react? So less reactive, less acidic, so this side of the reaction is favored. Okay, because it has the larger pKa. So I think that's everything for this. Hopefully that was helpful, and let me know if you have any questions. Good luck studying.